All right, why don't we start and get going? I'm Chris Tabor. Before we start, I'm going to say 4 different things, and then we'll get going. Thing number 1, I'm department chair here. So on behalf of the Department of Economics, welcome. We're glad that you come to Madison. We hope you enjoy our city. It's really a wonderful place, especially in the summer, and hopefully everybody will experience the terrace at some point you're here. Thing number 2, as department chair, every August or September, there's a meeting in this room of everybody in the College of Arts and Sciences, where we have to listen to the dean and all these administrators talk for 5 hours. So if you think we're boring, I don't have any sympathy for you. The third thing that I'm going to say is Rasmus has seen this paper 1 million times, so I ordered him to go back to his office, which means the rest of you have to step up the questions a little bit. And then just the fourth thing I need to say is more of an introduction to this. I think I'm less of a computational person than the other people that you've heard from today. So for me, it made the most sense to present one of my own papers as a paper from a few years ago. I thought it was the most natural thing to do. Please ask questions. It's always weird presenting something like this because I don't know how long it's going to take. Yeah.
Also ask a question on the chat there. It's very easy. Just type it.
And on the chat, feel free to ask questions. Feel free to answer them too if you want. That would be even better. Okay, so this is a paper that's published a few years ago. It's joint with Runa Valen. Basically, this is going to be much more of a labor economics talk. So if you're a labor economist, hopefully you'll find it interesting. If you're not a labor economist, you're going to see labor is actually pretty easy. We don't have that many things to think about. So in labor, these are 4 of the most. I might argue the information is the one thing I'm not dealing with that. Other than information issues, I would argue these are the 4 most important models in labor in terms of thinking about earnings inequality. And if we think about the kinds of models that structural models that labor economists look at, they tend to incorporate things like this. These are the main kinds of things that people think about in terms of the labor market. So the 4 models that I want to think about are going to be the Roy model, the search model, the compensating differentials model, and the human capital model. So there's not much of a literature distinguishing between these. So basically the goal of this is to write down a mega model that's going to incorporate all these things, and then we're going to understand the differences in the contribution of these various features to earnings inequality. So which is the most important for earnings inequality? Okay, so what do I mean by these things? So basically, Roy model is going to mean heterogeneity in pre-market skills that are varied across individuals and jobs. So we're going to have people are going to be choosing different jobs. And by the way, for the next hour and a half, the word job, the word firm, and the word establishment are synonyms. I'm going to use job to describe what I'm thinking about, and that's the way I'm going to be thinking about it. In the data, it's going to be establishments. So Roy model is just differences in its comparative advantage and absolute advantages. So some people will be good at lots of different stuff. Some people are be good at some jobs and not other jobs. I'm calling Roy model is the skills that you have when you enter the labor market, and I'm going to distinguish that from human capital, which is going to be different. But notice that an awful lot of the skills that you have at labor market entry is going to come from human capital. I'm just not modeling this. Okay, so Roy model inequality. It's not like human capital. Human capital is just human capital that's accumulated after you've entered the labor market. So that's what Roy model inequality is. What compensating differential, this is the term that I got into arguments with people about exactly what it means. What I'm going to mean by compensating differentials is actually heterogeneity and taste for different jobs. So different people are going to like different jobs. So the reason why it's important for think about earnings inequality is I can have 2 people with exactly the same level of skill and exactly the same job options right now, but one chooses to be a teacher and the other one chooses to be a stockbroker. Okay, that's going to lead to earnings inequality because of preferences rather than any of the other things that I'm going to think about. Now, compensating differentials, it's different than the others because it could go the other direction. Compensating differentials could actually decrease earnings inequality when you combine them with these other things. Search, I think, is relatively straightforward. Just by search, I mean you can't always get the job that you want, but you might have to wait. You might have to wait for it to arrive. Human capital, we kind of have it because we have to have it. It's not really the focus of this. Partly because I've written lots of other papers on human capital, and that wasn't. We're dealing with it because we need to. It's not really one of the main features, which I guess is why it's not in the title. Why the other three are. Human capital is going to be about as simple as it could possibly be. It's just going to be learning. It's going to be learning by doing, Ben Parath kind of stuff, and it's going to be completely general. So it's going to be equally useful on all jobs. So basically, the goal of this work is I'm going to write down. I guess I can look over here, so I'm not turning my back to you. I'm going to write down a model that's going to incorporate all four of these things. So I'll start by writing down the model. We're going to think very carefully about nonparametric identification. So we prove nonparametric identification of a version of the model. And actually, it's not fully identified, and I'll talk about that a little bit. There's aspects of the model that are not identified. Then we're going to estimate it, and then I'm going to use it to decompose earnings inequality. So I'm going to get rid of features one at a time and see what that does to earnings inequality. This isn't going to be a simple decomposition in the sense in the order in which you get rid of you get rid of things matters, but I think it matters in an interesting way. So we'll see that in the end. We get different results depending on how we do it. Another thing I say about this, and partly why I wanted to present it here, computation of this model is going to be trivial. Okay, it's basically closed form. So when I'm estimating the model, I'm solving we solve the model like 1,000,000 times every time we did a function evaluation, because it's that simple to solve. Which I think is useful in something like this, because I think adding things is probably going to make it more complicated to estimate, but I think it's still going to be quite feasible. Okay, so first of all, it's sort of I don't know what. Partially, the word partial equilibrium and general equilibrium are totally messed up. But now, anytime anybody does equilibrium, they call it general equilibrium. And just if you just have wage taking, you call it partial equilibrium. So I hate these words. But in this is going to be a search model. So the basic form is going to look like a search model. But we are not modeling firm entry or exit. Okay, so we're not going to have a matching function or anything like that. Firms are not going to be completely passive though, because we're going to have bargaining over wages. So the one thing that firms are going to do is they're going to bargain with workers across wages. Other than that, firms are not going to be particularly interesting. So here's a basic highlight of the way basic highlights of the model. There's going to be a finite number of types of jobs that one can get. In the data, it's going to be 100 different types of jobs. So we're going to model those j equals 1 to cap j. J equal to 0 will be non-employment, so absence of any type of a job. The way that we're going to model human capital is we're going to have levels of human capital, psi sub h, where h there's going to be a finite number of levels of human capital. So the little h will start to be 0, and then it's going to march up. The way it's going to work is that human capital is going to stochastically evolve. So you're just working along, and then you get this aha moment. You become a little bit smarter, and then you just keep marching. And it's going to be a random process. But there's going to be some maximum level h. It's kind of interesting. This is going to be a continuous time model, but the way that we solve it is going to look more like a finite time model, where h is kind of like time. We're going to solve the model backwards, starting with capital H and then moving backwards. Pi ij, this is the key Roy part of this. This is the productivity of worker I on job j. We're going to be very general with how we allow this, and there's going to be lots of heterogeneity in that. And then the way that wages are going to work is that what I'm going to negotiate over is a rental rate on human capital. Okay, so my wage is going to be R times psi h, where R is going to be the rental rate. And what this means is that when my human capital evolves, my wages are going to naturally evolve. So I don't have to renegotiate the contract every time. I don't have to renegotiate the contract to get wages to respond to human capital. This is one of these things that are indeterminate. There's multiple ways that you could do this, and this was just a convenient way to do it. And pi ij, by the way, works the same way. Your productivity on the job is pi ij times psi h. So pi ij is the maximum value of R that the firm would ever be willing to pay. And then the flow value that individual I is going to get flow value uij from job J. There's going to be no borrowing or lending, as there typically aren't in search models. It'd be great to add it, but it's very difficult. So this is going to be the utility. The person I with human capital H is going to get in job J when they're paid a wage of R, a rental rate of R. Yeah.
Just to clarify, there is no depreciation of human capital.
There's no depreciation of human capital. Yeah. It would be relatively easy. It would be relatively easy to add. It's not going to be super easy to add because you no longer would do the.
Exactly.
Yeah, you would have to solve the whole thing all at once rather than solving it backwards. But other than that, it would be pretty straightforward to add. Yeah.
Yeah, hi. So also, is it just random how much human capital you have, or is it determined in any way on what kind of job you have?
It's random. Yeah. That's the sense in which I mean it's the simplest model of human capital you can write down.
Okay.
Yeah. I have another paper that allows for much more general human capital that allows different types of skills to vary differently on different kinds of jobs. But this paper is just very, very simple in terms of human capital. Adding, that's the sort of thing that I think adding into this model I don't think would be challenging. I mean, we're doing it in a very different context, so it's not this kind of a model. But I think you could very easily take this model and make the human capital process much more interesting.
Thanks.
Okay, so we're going to take time. So time is going to be continuous. So Peter set me up pretty well by talking about continuous time, but he also kind of made it difficult for me because his whole paper was about epsilon. In my model, there's no epsilon. Everything is like if you look at everything that I wrote down here, there's no t's, right? So there's no. Your tastes do not vary across time, and your productivity does not vary across time. Has a little bit of discussion, like how you want to do that in a model like this is more complicated. Like the epsilon makes sense in a model like this if you think about people switching jobs. So there's a cost of switching jobs. But if you think about it as a taste for a job, it's more complicated than that because you want persistence. Right, so it doesn't make sense that I'm going to have my job today, and then a second later I'm going to have different preferences for the job. They're going to. So thinking about this in a more general way, I think it is an interesting thing. But right now, the only uncertainty is going to be about the arrival rates of jobs and job destruction and things like that. There's going to be no uncertainty about taste, and there's going to be no uncertainty about productivity. So delta I is going to be the job destruction rate. So this is the rate at which person I loses their job. We're going to have arrival rates for workers. So there's going to be an arrival rate if I'm currently employed. There's going to be another arrival rate if I'm currently non-employed. Lambda H is the arrival rate for human capital. We're going to argue that it's essentially a normalization. We're just going to normalize that equal to 1. It's not exactly a normalization, but there's. The way that we're estimating it, it's not a very strict thing to do. And then we're going to add one more thing to the model, which is this P star. P star is the probability. So delta I is the job destruction rate. That means my job is gone. My productivity fell or something happened. I'm out of a job. P star is the probability when I lose my job, I immediately get another one. okay? And that's going to account for the fact that a lot of job-to-job transitions are involuntary. So you do see people get fired and then find a new job immediately, or quit and then find a new job immediately after they quit. We kind of know what that is. Often it's you got the job offer and you decided to work for there before you actually got fired. So we're going to allow for that. We're going to, and that's sort of well identified from the data. It's like the way that we're identifying things. It's important to incorporate that because we're going to use a reveal preference argument. So essentially, to estimate compensating differentials, we're going to be using reveal preference. That is, if I move from job A to job B, that means that I prefer job A to job B. If they're involuntary, we can't use that argument, so we need to incorporate that in what we're doing. And then, so VIJH is the value function for person I at job J with human capital H when they're paid a wage rate of R. Okay, so that's going to be the key thing. We're going to also have VI naught H is the value function if you're non-employed. So this is somebody who currently doesn't have a job. This VI naught star thing is involving the P star. So this is the value function if I get fired. So this one incorporates the possibility that I might get this immediate offer, and this one doesn't. If you know the search literature, these things are called Godfather shocks. That's an offer you can't refuse if you haven't seen The Godfather. If you haven't seen The Godfather, you should also see The Godfather because it's a great movie. It's not actually true in this model because you can refuse it. So in our model, there are going to be jobs that you prefer non-employment to, which makes sense with compensating differentials. There's some jobs you absolutely hate that you're not going to do or you're not very productive on. So you could get this P star offer and still choose to turn it down if it's a job that's not good enough. Okay? And that's kind of it. Like, that's the model. There's a lot more stuff going on to think about it. But this, yeah.
Yeah, so it's just to return to the human capital, sorry. Now that I saw this, then it just seems, I don't understand the human capital, like what is the interpretation of it? Because if they just get random human capital while they are unemployed, and I haven't seen you talk about education, so if human capital is not education or experience on the job, then how should I think of it?
It's basically experience on the job. The only way this human capital stochastically arrives only when you're working.
Yeah. Okay, that makes sense.
Yeah.
Okay.
Yeah, and ideally, I mean, you could be relatively straightforward to have depreciation when you're not working as well.
Yeah. Okay.
Yeah.
And there's no education level in this model.
Education is going to be embodied in pi IH. And maybe in UIH, it could affect your preferences as well. But the assumption is going to be the education decisions are done. So we're taking people as they enter the labor market and saying, these are the different forces. Which of these forces are important? So the Roy model is going to turn out to be the most important for earnings inequality, which might not be that surprising if you think about it hard. You know, how much of that is from education? How much of that is neighborhood? How much of that is from parents? We're not answering that at all. So what we're looking at is differences at skill level when you enter the labor market, not where those things came from.
Yeah. Okay.
Yeah.
Thanks.
Yeah, and I might even argue this is an argument for education in the sense that I think if I think the main thing that's determining earnings inequality is pi ij, I want to increase pi ij for people, I would argue that education is the best way to do that.
Thanks.
But we're not modeling it explicitly. So at some level, that's the main part of the model, and I'll start with the end. I thought I had this statement somewhere. I maybe had this statement in a slide and I forgot about it, but the goal here was not to write down the most complicated model that I can and show off my computational skills, which here I wouldn't be doing anyway, given the other people that are in the room. The goal was to write down the simplest model that I possibly could that captures the essence of the models that I'm trying to get. That's a goal of what we're doing, and it's also partly why I think I think this is a model that lots of people could potentially build on and use as a basic framework to add other interesting things onto. But even though this is a relatively simple model, it already picks up the key features of the things that I want. So the parameter lambda JE, the arrival rate of jobs while I'm working, is going to pick up the importance of search frictions. You could argue lambda, the unemployment one does as well, but if I think about earnings inequality, it's more about this one. Okay, so I could have unemployment, but you can get any job immediately, and I would get that by sending that thing to infinity. Okay, so lambda JE is going to kind of be the key parameter that's picking up the importance of search frictions. The larger is lambda JE, the less important are going to be search frictions. The distinction between UIJRH and R psi H is going to pick up compensating differentials. That's the fact that people are not just maximizing wages, they're maximizing utility, and they might choose a level of utility that gives them higher utility. They might choose a job that gives them higher utility than a job that they had offered, but lower wages. So that's a reason why you get earnings inequality, and that's incorporated in a relatively simple way, I think. The pi ij is Roy. That's the Roy model. The fact that pi I varies across I and varies across j is Roy model heterogeneity. After there's going to be bargaining in the model that we'll talk about, and then the increase in H is going to pick up the on-the-jobs learning. That's it. That's the basic essence of the model. There's going to be some more stuff coming that are going to make it look more complicated, but that's the essence of what we're doing. We're going to estimate these things, and then to decompose earnings inequality, we're just going to get rid of these things one at a time and see what's most important in determining earnings inequality. And you can almost see, it's almost obvious how we're going to do that. How do we get rid of search frictions? We just set lambda JE to infinity. You get your favorite job right away. Change preferences, so what you care about is wages, not utility. Okay, the one thing where this is not totally straightforward is the way the wages are going to be determined here. So wages in a search model, especially a search model with compensating differentials, are always a little bit complicated on exactly how they're going to work. We're going to, if you know Cahook, Postel, Binet, and Robin, you can fall asleep because there's nothing new here. We're just basically doing what they're doing. If you haven't seen it, I'll go through it to explain it. My guess is that probably most of you don't know it or don't know it super well. So that we're going to assume that the worker has we're going to estimate a value beta, and that's going to be the bargaining power of the worker. I said this already. We're going to bargain over wages, and what we're going to be bargaining over is the rental rate of human capital. Okay, so human capital goes up, my wages are going to go up. So it's R that we're going to be bargaining over. R is going to stay fixed until one of the two parties wants to renegotiate. Okay, and if the participation constraint binds, we're going to renegotiate, and we're going to get a new value of R. It's always going to go up. Another thing that I don't particularly like, but is really difficult to solve, full information here, which is a really strong assumption. So not only does the firm know instantly what your productivity on the job is, they know what your productivity on all other jobs is, and they know what your taste of the jobs is, and they know what your taste on all other jobs are. Okay? It's a really strong assumption. Relaxing it is difficult, because you have this continued relationship. So the firm is going to eventually learn something about your taste based on the decisions that you made. So it becomes a really difficult problem. I've thought a lot about that, and I don't have great ideas on how to fix it. Okay, so non-employment is going to be relatively straightforward. Well, a worker is going to get an offer from non-employment. As I said before, they're not going to take all jobs. So there's some jobs at which, even if you paid the worker the pi ij as the rental rate, they still would prefer to be non-employed to take that job. either because they don't like the job, or they do like working, or they want to wait for a better offer. If we decide to, if there is a surplus, we're going to bargain the surplus, where beta is going to be the bargaining power of the worker. So if beta is equal to 1, I get the worker gets the full surplus. If beta is equal to 0, the firm gets the full surplus. Okay, so that's that part of it. This part of it, the next part of it, is more interesting, where I'm working at a firm and I get an outside offer. Okay, so I'm sitting in my office, which is on this floor at the end of the hallway. I'm sitting and the phone rings. If I answer, I don't answer the phone anymore because it's always the wrong number. So I get an email. The email says, you have a job offer. Would you like to leave Wisconsin and come to the new job? Basically, one of 3 things could happen. Okay. One is it's not a very good. It's an offer to work at Burger King as a line cook, which I don't particularly want to do. It's probably going to pay me less than my current wage. So I just say, no, thank you, I'm not interested. I don't bother to tell the dean that Burger King called me up and made me an offer. That's one extreme. The other extreme is I get a great offer. Okay, so the Milwaukee Bucks call me up. They say, Damian Lillard's hurt. We need a new point guard. Chris, would you like to play point guard for the Bucks? And I say, absolutely. At which case, I tell Wisconsin that I'm leaving. I take my car. I drive to Milwaukee immediately, and then we're going to negotiate a wage. Okay, and the way that this is going to work is the new wage will be, if I have all the power, I can extract all of the rent from the Bucks on having me as their point guard, which I'm sure is a lot of money. If I don't, it's going to be basically somewhat like a second price auction. So what they're going to this is going to be the value I would get at working at Wisconsin at the maximum wage that Wisconsin would ever be willing to offer me. Okay, there's multiple ways to do it. That's the way that Postel, Vinay, and Robin do it, and we're using their way of doing it. So you could make this. There's other ways that you can do that. That's how we're doing things here. Okay, here's the intro. Whoops. Okay, here. Oh, I said the wrong thing. That was the Bucks. That's Burger King. The most interesting case is if somebody calls me up and it's a competitive offer, but it's not as good as Wisconsin would be willing to pay me. That is, they come to me, they offer me a salary that they say that at the salary they offered me, I would choose to leave Wisconsin to go there. But Wisconsin can respond and give me a raise in order to keep me to stay. Okay, that's kind of the most interesting case. So I'm going to get a raise from Wisconsin because they want to keep me, and the way that we're going to bargain the raise will be exactly the same way. Okay, so it's going to be completely symmetric. You have 2 firms that have this game that they're playing against you. The way you're going to go to the one that has a higher total surplus, and the wage that you're going to get is going to be determined by this generalized Nash bargaining type of thing. Okay, does that make sense? Yeah.
So what I understand is the wage is determined after the match happened. Like when you move the new job, then how can you know the surplus on the new job is greater than your current job?
Let's say it again. So I get it. Like simultaneously, I have 2 offers, and I'm deciding between the 2 of them.
But isn't the new jobs offer doesn't have a wage because the wage is determined after the match?
It doesn't really matter because I know everybody knows everything. So I know the maximum wage they're willing to offer me. Right, so it's going to turn out, I haven't proved that, but it's going to turn out that I'm going to go to whichever of these is larger is the one that I'm going to go to. And then this is the wage that will be determined there.
Thank you.
Okay. Yep.
So I have a question about the bargaining power. In this case, you just can bargain about the wage, but it could be could be a difference if you include some more than wages, like flexibility.
Yeah, that's a good. In this yeah. Right now, the compensating what I'm assuming is the only thing we can bargain over is wages, right? And what I'm assuming is the compensating differential part, the taste for the job, is fixed. That's not something I can bargain over, okay? And I'm going to argue that that's if I think about my utility for being an economist at Wisconsin, the main thing is my utility being an economist for Wisconsin. I can bargain over which office I get. I can bargain over. I mean, actually, in our case, we can bargain over teaching, which maybe that was a bad example because, but mostly what you care about is that the key thing that I think is most important about compensating differential. It's not to me. It's the job itself. Like, is this the kind of job that you enjoy going to work to do? So that's not something that can be negotiated.
But for example, if you care working in your house or working in the office, that is also a taste, right?
Yeah.
Can be, but it's not.
You absolutely could put that into this model. Yeah.
Could be that in that way you have another variable that you bargain.
Right.
Okay.
Yeah. You could. You very much. You could just have. Yeah. You could make UIJ depend on something else other than just wages and have that bargain over. And it's pretty clear with the firm. I mean, those models are actually relatively easy to solve because you're going to be on the frontier you can basically in some sense, you can just give the worker money and they can choose how they want to allocate it. Do they want to spend it on the job or do they want to buy the ability to work from home from the firm?
Okay, thanks.
Yep.
Okay, sorry. So it's just something I didn't understand completely. So if you got this third option, if you got such an offer where you want to renegotiate, so where is your outside option here, and how are you renegotiating?
This is the. Okay, this is. Which one am I looking at? Yeah, so this is if I stay. So this is my value function on the current job. This is the value function on the alternative offer that I received. Okay, so it's a generalized Nash bargaining thing where this is between this and this. Does that make sense?
Yeah, that would be the. Okay, I think I'll need to think a little bit forward.
Yeah.
Okay.
I mean, there's a messy thing here. Like, if this firm knows that they're going to lose, why do they even bother to bargain, right? That you can get into these kinds of questions, and there's other ways to set that up. But this is the way that we're doing it.
Thanks.
Yep. Okay, so now Peter set me up for this, so you're used to seeing continuous time things before. This is the value function. It looks complicated, but it's not really that messy. It's not really that bad, even though it looks pretty messy. This is the annoying continuous time stuff that you get, and if you're used to thinking about continuous time, you know what that is, and if you're not, don't worry about it. What's on the right-hand side is what's interesting, and this is going to incorporate all the things that can happen. So we're going to start with a flow utility. Okay, so this is the flow utility that I get on job J with this level of human capital and with that negotiated wage. So that's just flow utility. This is the job destruction probability. So this is what happens if I get fired. That's my value function if I get fired. This is the human capital accumulation rate. So if my human capital goes up, I'm going to move to that value function. This thing here is incorporating the renegotiated wages. So this is what's going to happen if I get an offer from firm L that is high enough that I want to use them to renegotiate, but not high enough that I would actually leave. Okay, and then you've seen that before. That's the value function that I get. And then this thing is going to be the value function that I get from the bucks. So when I get an offer from a job that's so good that I'm going to actually leave. This thing here is a little bit messy. This is just this, and it's going to matter. You're going to see it again. So you need to worry about this stuff. Peter had things like this and showed you why you get things like this. But this is just the sum of all of the relevant lambdas. It's the sum of it's lambdas that I wouldn't even bother talking to. They don't need to show up. But these are all of this is the total sum of the arrival rates of every single relevant job offer that might change things. Okay, so that's the value function. Identification. So a big thing that we did was think very closely about identification. This is the first time I think I presented this paper since the paper was published, which means I'm allowed to complain about the referees because they can't stop the paper from being published anymore, just get mad at me. But this is the thing, we had this like nice intuitive proof on how identification worked. It wasn't formal, but it just kind of went through it, and the referees said, no, we don't want that. We want a formal proof of identification. There's now a formal proof of identification, which is like 80 pages long, which I doubt that R2 ever bothered to read. But took a fair amount of my life to do that. And the intuition worked. I mean, everything was right. I mean, there is some value to actually proving things rather than just saying it. But it's just like you have to go through every tiny little step and verify that it works in every condition, which it does, but it was a lot of work. What's interesting here, I think, is what's not identified. So, I can identify the rates of transition. That is, I can identify the deltas and the lambdas, basically by the rates at which people switch jobs. I can identify the taste. I can identify the taste for all of the jobs by reveal preference. So if I see a voluntary job-to-job transition from A to B, that means that I prefer job B to job A. And if I'm willing to take a wage cut to do that, that's evidence that compensating differentials are important. And then the Roy stuff is identified because I panel data. I get to see the same worker on different jobs, and that's gonna tell me something about that. So for the most part, this stuff is identified. There's two things that are not identified. And the first one, I guess this is actually where I kind of like R2, because we proved formally that beta is not identified. What we can identify is we can identify how R changes, how the rental rate changes as a result of this bargaining process, as the result of getting outside offers. Okay, so we can see how much R changes. So we can do the following thing. If beta is equal to 1, that means there's no change in R. If there's no change in R, beta is equal to 1, you're done. So we can identify beta is equal to 1. But if beta is anything different from 1, we cannot formally separate beta from preferences. For example, if I see very small changes in R, so I see R doesn't change very much, that could be because of two things. It could be because beta is really close to 1. Like if the worker has a lot of bargaining power, you start with a really high wage. There's not that much of a wedge to go up from there. So that could mean that beta is close to 1, but it could also mean that I'm essentially indifferent between different jobs. If I'm almost indifferent between different jobs, you're also going to find very small changes in R. So putting the compensating differentials into this, like in the standard model, it would be identified without the taste. If all you were doing is wages, then it would be actually pretty easy to identify. But because of these utility things, we cannot separate beta from the magnitude of the utility shocks. Okay, and what's weird about that, though, is that we're kind of if you think about where beta, I mean, first of all, beta is a weird thing. Like, is this a structural parameter or not? I don't know. Like structural in the classic sense. If I change the policy, will beta change? I don't see why it should stay the same because we don't really know what it is. But it's also true that it's going to be we're going to identify beta from a normalization. We're going to normalize the utility shocks. And that's going to give us identification of beta. But that's kind of weird when we think about the decompositions, because if I think about doing things like changing given that beta is identified by preferences, if I think about changing the counterfactual where I change preferences, it's weird to change preferences, but it's not only weird, it makes no sense to change the preferences but hold beta the same. Okay? We're going to deal with that when we do the decompositions. By setting beta equal to 1, it's going to be one of the very first things that we're always going to do. Yeah.
Sorry, just a very small thing. Do you model any variation in the wage without a new offer coming? So say I just get a raise during my current job?
No.
And in that case,
other than human cap, I mean, that is why it is important for us to accumulate. But other than that, we don't. We have measurement error in wages, so that's how we're going to deal with it.
I'm not very familiar with this literature, but how bad would it be to assume that the firm is just going to match whatever other offer I get, and we're not going to bargain? So if I get the second offer, they're just going to match the second offer?
That's a special case of this model where beta is equal to 0.
Okay.
But we're going to estimate beta. Yeah. It doesn't fit the data very well. And it doesn't fit the data it fits the data worse here with compensating differentials because you see huge variations in this thing, right? Because once you could have put in preferences, I have a job that I like a lot. Like when I come from non-employment, I'll pay you in order to work for the job. So you're going to see huge. So the first version of this model, we estimated like that, and it was horrible. I mean, yeah. Now that I know that it wasn't identified, we could have played. Actually, I think there's a version in the paper where we changed the normalizations and we did that. Yeah.
This might not be the focus of this paper, but just out of curiosity, how do you get the measurement of labor market frictions from the lambda E?
Say it again.
How do you measure the labor market frictions from the lambda E, the job-to-job transition rate or the job arrival
I just
rate?
when I do the decomposition, I'm going to set lambda E to infinity.
So do you estimate it from the data?
No, we're going to estimate it from the data. We're going to estimate lambda E from the data. And then when we simulate to get rid of market frictions, essentially what I'm going to do is say as soon as you find a job, you just go to your favorite job immediately. Okay.
Why can't you, can you see in the data, like if somebody got a job offer from the same job type from 2 different firms of that job type? And beta is the same across firms, right?
In principle, In principle, we could try to do something like that. We're not trying to do something like that. It's not that easy because the firm types are unobserved. So, we're not, and for us, it's very much a random effect kind of model. We're simulating the whole thing. We're not identifying different firms to different, yeah. Okay, the other thing that's not identified is like, this is something I would harp on a lot, is people don't understand identification of selection models. So there's this idea, people think selection models are like instrumental variable models. I need an exclusion restriction to identify a selection model, so I just need to find an exclusion restriction, which is hard. Okay, but it's way harder than that. Selection models are basically require an identification at infinity argument. Not only do you need an exclusion restriction, you need an exclusion restriction that has enough power that you can move everything that you want to be. It can move you anywhere you want to go. So if you think about this, if I was going to estimate this model in the US, I would need exclusion restrictions, but I would have, part of the model would be the wage that Elon Musk would get at McDonald's, right? That is part of the model. There's no way that I'm going to find an exclusion restriction that's going to force somebody like Elon Musk to be working at McDonald's. It's going to be impossible to find that thing. Not only that, I have 100 different job types. I need 100 instruments like that. Like I need to be able to move every single person into every single job. That's how hard the selection problem is here. It's not just coming up with one instrument to solve this. It's way, way harder than that. Okay? Our solution to that is to say, who cares? It's not very interesting. Like, I don't really care. There's no interesting state of the world where my counterfactual is going to involve Elon Musk working for McDonald's. So what we're going to do is we are going to, non-parametrically, we cannot identify the model. Parametrically, we could. So we're going to have parametric restrictions, and presumably we could, but we're going to respect this when we do the counterfactuals. So when we do the counterfactuals, here's how we're going to think about it. Suppose there's 6 types of jobs. And we have a person here. This is their utility from non-employment. So in the world and the data, they would never take E and B. There's no state of the world where we would ever see this person in E and B. When we simulate the counterfactuals, we will never put that person in E and B. So it's really only matters for the compensating differentials. When you think about search, that's not a problem. If you get rid of search frictions, you're just going to go to C right away. Okay? The real problem will be if I get rid of compensating differentials, it's quite possible this is the highest wage job that I would receive, but it's just something that I would absolutely never do. The data's not going to tell me that. So when we do compensating differentials, we're going to get rid, the way that we'll do the counterfactual is you will only care about wages, but we'll still condition on being in the choice set. We'll still condition only on the blues. So we'll think about compensating differentials. They can change the ordering of this, but they can't get you to go to those jobs. That's how we're going to deal with this. Okay. Econometric specification is going to look relatively. I have till 5:20, right? Oh. Why does information about the wage tenure slope fail to identify bargaining power? It does. Like that, the information that we're going to be using, you have this, what you can't tell the difference between is the power, it's sort of the magnitude of, it's the magnitude of borrowing, let me say it a different way. We have this, there's this normalization that's an issue. So we can't separate taste from the level of taste from the level of bargaining. Okay, we can't separate those things. We're going to normalize taste, but then using the wage tenure slope is exactly how we're going to identify the bargaining power. Okay, so it's a question of, so what bargaining, my whole argument was if you see a small tenure slope, right, that could either be because beta is close to 1, or it could be because people are close to indifferent between different jobs. You can't tell those two things apart. But you can tell that it's one of those two things, which is going to suggest that wages aren't going to move very much. Okay? So we're going to normalize taste, and we're basically going to use the wage tenure slope to identify bargaining power. I don't know, does that answer the question? Okay. A number of papers have done this. Actually, I think we were the first, so I think they're actually using our idea to do this. Okay, here's the econometric specification, which will be relatively straightforward. The pi ij, it's almost too straightforward, and that it gets people thinking about things in ways that they probably shouldn't be. Log pi ij is, there's going to be a permanent component, which is permanent to the person. There's going to be a job component, which is permanent to this is going to be the establishment. So when we estimate in the data, this will be at the establishment level. And then there's going to be a Vij, which is going to be an idiosyncratic match between the worker and the firm. We talked about this. That's a flow value to a firm. We're going to assume that we observe wages with measurement error. So this is a dealing for the fact that wages do bounce around. They're not exactly the same. So we're going to have some measurement error in wages, which is going to be important. That's some of the variation in wages. You might call that a failure of the model, and maybe that's right, but that's what we're calling it. And then utility is going to be similar. We're going to use log utility, which is really nice for a whole bunch of reasons. And then we're going to have something similar. So there's going to be a taste for the firm that's permanent for everybody at the same firm. And then there's going to be an idiosyncratic match between the worker and the firm. We will assume that this is very important. Offered wages, something that I think the referees also didn't always understand. We are assuming that these are independent in terms of offered wages. They're not going to be independent. That's the selection problem. The selection problem is they're going to be strongly correlated. Everything's going to be strongly correlated, conditional on looking at actual wages. But the offered wages, we will assume that the theta, the mu's can be correlated with each other, the v's can be correlated with each other, but the theta will be independent of this, will be independent of that. Okay? So that's the basic parametric specification, flow utility for non-employment. It looks kind of goofy, but I don't want to. Estimating it that way was nice. The way that we're doing human capital, we're not assuming. If you know something about labor, human capital, you have this Mincer thing. So human capital tends to go up and then slows down. We're choosing a functional form, so it's a cubic. But there's only be two free parameters because we're imposing this. So basically, it's going to go up and get flat, and then it's going to stay at h forever. So it's basically getting to a level and then flattening off. Okay. We're going to parameterize the model in the following way. Stuff is normal, except for the firm types. These are going to be discrete uniforms, so the mu's are going to be mixtures of discrete uniforms. These are two normalizations that we can make for various reasons. I'm not going to talk exactly about why. Often they're normalizations. It's less obvious that they're normalizations here, but they are.
Sorry, here. Theta is ability of the worker? That's just a question.
What?
Theta is the ability of the worker? Theta.
I mean, theta I wouldn't call it that. That's exactly what I don't like. That's what, when you think about things like in an AKM way, that's the way that we think about it. To me, the ability of the worker, the ability of the worker is this vector of pi ij, which is 100 different. You have 100 different productivities in all of these different jobs. Theta I is a parameterization, a way of parameterizing that 100-dimensional distribution. I mean, at some level, all three of these things are you might say this is the absolute advantage of the worker, and this is the comparative advantage of the worker. And then this is something about the productivity of the firm.
It's like a basic ability of the worker. It's like a base level or something like that.
To me, the distinction between theta and v is not that. To me, this is just a parametric form of modeling pi. I don't want to interpret. This has no. I'm saying this, but it's not going to be true when we do the decomposition because the referees wanted me to do it that way. But yeah, I would prefer to think of pi ij as what's in the model. This is just a parameterization for the model.
Okay.
Yeah,
because I was a little confused because later you have an equation for human capital, and I was thinking that theta was related with the age.
No, theta is complete. Theta is the psi h is just this random thing that happens. It's uncorrelated with everything else.
Okay.
Yep. Yeah, you could easily actually add heterogeneity in the accumulation rate. You could also allow the form of that to vary across people, but we don't. Okay. So that's it. That's the model. We have 18 parameters, which for me is not very many. I want to talk about computation. This is something. My slides weren't ready until today, and the reason my slides weren't ready today is because I added this, because normally in a seminar I wouldn't talk about the computation of this, but given this kind of conference, I think it was important to talk about. So there's a lot going on. So there's lots of different moving pieces, but it turns out that this model is trivial to compute. It is almost reduced. It is almost completely direct, getting everything. I'll show you where it's not quite close. There's only one little part where it's not quite closed form, and it's a very simple thing. So for a given we're going to solve the model for a given person. So I'm not going to be integrating across people. We're going to solve it. I'm going to draw all of these variables, right? And it's a lot of them. It's like 200. It's more than 200 different things that I'm drawing about the person. Then I'm going to solve the model for that draw of the person. there's going to be H levels of, but the key thing is the conditional on that. For a given worker, there's only a finite number of states of the world. There are H different, actually H plus 1, since 0 is a possibility. There are H plus 1 levels of human capital, J types of employers as well as non-employment. Utilities across all jobs are known, so there's no shocks here at all. Interesting to add, I have lots of thoughts about that, but we don't now. So utilities are just constant over the life cycle. So the way that it works is that we're going to just backwards induct. So we're going to start with H. We're going to start with capital H. We'll solve for that, and then we'll go to H minus 1, and then go back to the beginning. For simplicity, this doesn't change like the tricks that work. But I'm going to ignore we're going to ignore the Godfather offers. Okay, so you go straight to non-employment. There's no possibility of these other jobs. Not a big deal, but it's adding in another feature that's not particularly hard to deal with or interesting. Okay, so this is what the model looks like when H is equal to H. So these are the components. This is the value. This is the value function that I get on the job. It's the same as what I showed you before, except that we're at the maximum level of human capital, so there's no longer this option to get for your human capital to go up. This is going to be the value of non-employment, assuming that we don't have this V star thing anymore. And then these are the lambdas. So these are just the jobs that matter here and for here. That's the model. That's the model with H. What you will notice when you look at this is what shows up mostly on the right-hand side is V's evaluated at pi. Okay. The R stuff doesn't show up very much. It shows up here, and a little bit here, but not really. I'll say what I mean by not really. So what we're going to do is solve for all of these V of pi H's. Okay. And then once we got that, it's going to be relatively easy. Solving for the V of pi H's is also almost closed form. So what I'm going to do is what's going to matter for the person is going to be their value function across the different jobs. Not surprisingly, I can just look at the flow utility. So if I'm going to order jobs from 1 to cap J based on your preference of the job. So cap J is your favorite job that gives you the highest level of utility if I could extract all of the rent from there. And now this is it's always going to be the case that if I have an offer, once I've done this, if I offer from 2 jobs, an L and a J, whichever of those is higher is the one that I'm going to go to. I'm always going to go to the one for which this thing is higher. Okay, it turns out that I don't know whether you call this a trick or notational change or whatever it is. It turns out that I can just do this, right? I'm just going to define Vij star to just be equal to this thing. Okay, why you'll see in a second. The reason. Let's start with its favorite job. Okay, the favorite job. There's none of this business. Like it doesn't. I'm at the top. This is the best I can. I can never possibly find a better job or get a higher wage. Nothing's ever. So all of those lambda stuff disappear. So I get this really simple value function here. So divide by rho plus delta I, and then the Vij star is just going to be that object. Okay. Again, you know what that is exactly. There's no work to compute what that is. Then the cool thing, and this is algebra that I'm not going to derive, but it turns out that I can write for any j, I can write the value function at j as the value function at j plus 1 minus that thing over there, which involves the flow utility divided by some stuff. So the nice thing is that the value of the unemployment doesn't show up here at all. Okay, so now what have I done? I've solved all of the Vij stars. I start at the top, and then I start at the top H, top J, and then I move down to J is equal to 1. So now I have all these Vij stars. The one thing that I don't have is the value of non-employment. For the value of non-employment, this is the thing where I'm saying it's not quite closed form. Okay, for the value of non-employment, let L naught be the reservation job, right? We've ordered jobs in terms of orders. L naught is the job that is the first job that I would take. Anything below L naught I would not take. If I know what L naught is, then it's trivial to solve for all of these things, okay? So that's the only thing that's not quite closed form, but it's really easy. You just start at L naught at the top, and you move down one at a time until you find this case where the value of non-employment here is better than all of the jobs that are worse than there, are worse than that, and you're done. Okay, so that's the only thing that's not trivial closed form solution to this thing. Okay, now we've done H. Oh, we haven't quite. There's another thing that we need to do is also need to solve for wages. So I've solved the model. How am I going to get wages? How do I calculate the R? That's also going to turn out to be trivial. R only shows up in two places, but it doesn't really show up here. And it doesn't really show up there because for any R that solves the model, I know what lambda is going to look like. So if my outside option was J is equal to 3, what's going to matter is everything bigger than 3, okay? So I know what this has to be at the optimal R already. So I know this, so all I need to calculate is that. Well, I have log utility, so it's trivial, right? This thing, I just take the difference between those two things, and I get R immediately, okay? So that's it. So it makes that very simple to solve. Same thing for that was from non-employment. The same thing if we're thinking about an outside job. Solving the model for H for now we're going to go to H minus 1, and this should not be surprising to you. Rather than having utilities, we're going to have this thing here. It's the utility of the current job plus the basically discounted value of the future. I'm going to order things based on this thing, and then the algebra is a little bit different, but it's very simple. And I'm going to solve these things. I'm going to solve these things again in exactly the same way, or almost exactly the same way. Same intuition. Calculation of R is more complicated because now R shows up it's going to show up in two places. It's going to show up in the utility, but it's also going to show up when my human capital goes up, I'm going to keep my R, so it's going to show up there as well. It turns out with this model that it's still a closed form solution, but it's a really complicated, messy algebra to show that. But you still get a closed form solution. Notice if you got rid of log utility that would become much more difficult. Okay, it wouldn't be hard, right? You're solving one equation for one unknown, so it's not a real difficult problem, but it would be a little bit harder than this problem. Okay, so that's it. That's solving the model. Any questions about that?
Yeah, question. I know in like AKM land, we're thinking a lot about like who is switching and like what's the connected set. In this setup, you don't just observe, you're not just thinking about like in AKM, I'm thinking, oh, if we have a large firm with a lot of switchers, then we have a more precise estimate for the firm effect. How should I be thinking about like which individuals, I'm assuming like high quality employees, we don't really know too much about like what they would do in unemployment, whereas like lower quality employees, we see them lose their job more often. Should I be thinking about that when I see your estimates, like certain employees, certain kinds of workers have more precise estimates for these parameters?
So we're going to estimate the model by indirect inference. First of all, it's at some level what we're doing is fundamentally different from AKM in that it's a random effect model rather than a fixed effect model. So you should think about it as a random effect model. And even then, we're going to be using, so with the connected sets, you don't necessarily need to, that's not an issue with random effects. Then we're going to have some moments. We're going to use the moments to identify it. So I'm going to show you what the moments that we're going to use to identify it, and you can think about it there. So you should definitely be thinking about identification and where these things are coming from. But I will talk about that. And there's always going to be stuff to worry about, clearly.
Yeah, definitely. Yeah, I was just thinking someone who's getting a lot of offers, who has a lot of outside options, they're beta, we're probably going to know more about that because they're having more of those interactions. Like in your fully saturated thing, you're seeing them so much more than people who are not
Right.
getting more of this comparison. So I was just thinking when
Yeah.
we're looking at the estimates, if we should be
So
keeping
this
that in mind.
this is the magic of indirect inference. So I'm going to assume that the world behaves the way that my model says, and I'm going to look at the data. I'm going to look at the data assuming that it looks like this. So if that's like a violation of something, if you know that's going to be a problem if I made some parametric assumption that doesn't allow that as much as you might. Like, yeah, you might have people. Yeah, we don't have people changing. There might be people that change their preferences for what they like to do, every other week or something like that. That's not in the model. How that would bias things, we could potentially think about. So,
Thank you.
Data. So we're going to use match worker. So probably not surprisingly, given that I have I's and J's, if you're used to looking at I's and J's, you know that we probably are using match worker firm data. So we're using match worker firm data from Denmark. What's nice, actually, when we started this I started this project a long time ago. We started this project, we had a really nice aspect of this that wasn't true in other data sets that now tends to be more true. We know the exact date at which you switch jobs, which is important, because an important part of identification compensating differentials is we want to use this reveal preference argument, okay? But if I get fired from one job and move to another job, I don't want to use reveal preference for that. So it's very important that we observe job-to-job transitions, which we can in the data. The data that we're using is 85 to 2003. We're using people that are completely done with schooling. If you go back to school, we would only use your data after you exit school for the final time. Younger than 56. We're assuming an infinite. This is a weird sort of thing where we're simulating a life cycle model, but we're assuming that people are infinitely lived. Essentially, what we're doing is we're simulating you from the beginning of your life. We are assuming that retirement is sufficiently far away that you don't need to worry about it in making decisions. And I'll wave my hand and say that's what we're assuming, because thinking about finite life with something like this is going to be complicated. So we're going to for that reason we don't want to use people that are thinking about retirement. So we're going to use people that are younger than 56. And I realize this is the first time I presented this paper when I wouldn't have been in the data. Okay. Here, we're going to do indirect inference. So we're doing indirect inference. I'm going to assume that people know what that is. We're going to do it in a somewhat different way than people often do. Some people do it this way, some people don't, but we're going to have exactly the same number of moments as we do parameters. Okay, so for each parameter, we have this 80-page identification proof. For each parameter, we're going to think about what the theory says should be identifying it. We're going to look for an aspect of the data that's going to be identifying it, and we're going to pick that for that parameter. So for each parameter, we're going to pick one thing. Now, of course, it's a nonlinear model. It's not like all parameters identify all moments. But as a practical matter, this was really useful in practice when we were doing this, because I had I've written papers since then where I've been using indirect inference. Like right now I'm writing a paper with like 300 moments. That's better in the sense you got more data, so you should use the data to identify the model. Why not? But it's much harder to know what's going on. Like when we were working on this paper. By the way, another nice thing about indirect inference is that my co-author could run the model in the servers in Denmark, and then I could simulate the model here in Wisconsin and try to get the parameters to meet. So I was the main person that did the simulations. I have a very good sense of what's going on in the data. I understand the relationship between the data and the model and the estimates very, very well, and I think that's because we have 18 parameters and we have 18 moments we're trying to fit. I'm going to give you this identification map. So this is for all of the different parameters, the moments that I think are matching them. It's not exactly right, but it's pretty much right. Like I know in the data when I mess with that parameter, it's going to mess with that. Now when I mess with that parameter, it's going to mess with that one and that one. But basically these are to identify the learning by doing, so this is general human capital, we're going to use the coefficient on experience and the coefficient on experience squared in a regression that's controlled for individual by job dummies, okay? To identify monopsony, we can't, the coefficient on tenure is not identified in that regression because tenure and experience are perfectly collinear, conditional on staying in the same job. So we're going to use tenure squared, which is still right? It's picking up the speed at which the rate at which my wages stop going up in response to outside offers. So that's going to identify beta, conditional on our normalization of the error terms. Pre-market skills is basically we're going to do a variance between persons and a variance within people to get those parameters. To get the taste for jobs, we're using this reveal preference thing. This is going to, and then these things are going to be messy. To get the permanent, there's this permanent component of a job. To get whether, I can learn whether I like the job, but I also want to learn whether other people that do this job like the job. So we're using a reveal, if this is the kind of job that everybody leaves, on job-to-job transitions, we're going to say that's a job with a low taste, a low mu. If it's a job that everybody comes to from other jobs, we're going to say this is a job with a high mu, especially once we control for income. Search frictions, for a standard thing, the length of a job, the length of non-employment spells. And then this is going to be something similar. This is a correlation of wages within a firm. Yeah. Anyway, so I think you get the picture, and I'm happy to talk about this in detail with anybody who's interested. But that's what we do. We get a bunch of estimates. Here are what the I was thinking I had till 5:30. I have till 5:20. I probably shouldn't have spent that much time on that. We fit the data really well. You say your first thought is, oh, that's really great, and then your second thought is, wait a second, you have 18 parameters and 18 moments. You better fit the data pretty well. But then your third thought is, well, wait a second, it's a nonlinear model. There's no way, it's not guaranteed. There are definitely features that we couldn't, you can imagine features in the data that this model couldn't possibly fit. So we're going to declare victory. These are the parameters. Let me talk about the decompositions because this is what's interesting. So what we're going to do is we're going to start with overall earnings inequality, okay? And then we're going to get rid of these things one at a time. So we're going to eliminate human capital by just assuming that the speed of human capital is infinite. So as soon as you enter the labor market, you're at capital H, okay? That's going to be human capital. I can call it eliminating monopsony power. Like search matters here for two different reasons. Search frictions matter because they affect which job I'm working on, but they also affect the wage that I get in the job through this bargaining process. So the faster jobs come in, the more my wages are going to rise. So search matters two different ways. I'm going to call this monopsony power, but you could also think about this as part of search frictions. So we're going to set beta equal to 1. Those two I'm going to do immediately. This one because it's weird to do. I don't know how to do it later because it's kind of changing. Once I change the model, holding beta constant doesn't make sense. This one I don't want to spend much time on because we know the answer. If you run a Minter regression and you want to say how important are experience and experience squared in explaining log earnings, we know the answer to that, and it's going to be very similar to that. The more interesting one are going to be these other ones. I'm going to eliminate pre-market skills by setting the wage to the mean log wage by firm type. So I'm going to allow for heterogeneity across jobs, but no heterogeneity across people within a job. Okay, everybody's just going to get the mu j for that job. I'm going to do it, this I talked about, I'm going to do it two different ways. If you remember in log pi, there was the theta I I said was something like absolute ability, and the Vij was like comparative advantage. The referees wanted us to do them separately, so we did those things separately. I don't like thinking about that way, but I did it anyway, and it's in the paper, so I'm going to present it to you. Eliminating search is really easy. So we're just immediately as soon as you get a job, so you can still be non-employed, but as soon as you get a job, you're just going to move to your favorite job immediately. Getting rid of non-pecuniary aspects of the job is also trivial. We're just going to assume that you order jobs by wages, not by utility anymore. Okay, so that's what we're going to do. And here are the results. We start before with getting rid of measurement error. The variance in log wages is going to be something like 0.104. Now we're going to get rid of each of these things at a time. The order that we do things is going to be different in these different slides, but in an interesting way. So we get rid of learning by doing first. That affects wages by 10%. We kind of knew that already. Not that interesting. The beta doesn't matter very much. Getting rid of monopsony makes very little difference in this model. And that's partly because the data, the returns to tenure, is not really that large. And if the returns to tenure is not that large, there's not going to be that much of a role for monopsony. Then what we're going to do, in this case, we're going to get rid of Roy model inequality, and you can see that that does the bulk of it. We go from 0.09 to 0.007, and it's roughly half and half. How much is the theta and how much is the v? So this is going to say the vast majority is the vast majority, 0.093 to 0.08, is going to be Roy model inequality. Search frictions don't matter very much. That just brings you from 0.008 to 0.007. The 0.007 is what's left. What's left in that case is compensating differentials. Okay? So what are we finding? Roy model, super important. Search and compensating differentials, not very important. You can go through these different things, and they mostly don't matter. But to me, the one thing that matters, I'm taking the 5 minutes that Peter gave you. The importance of search matters. I did 4 different things. The importance of search matters a lot in these different things. In the first case that I showed you, it was 1%. In the largest case, it's 26% of earnings inequality. And so it matters the order that it does it. Why does it matter the order that it does it? It matters what I'm searching for. So there's 4 different things that I'm searching for. I care about the firm-specific wage. I care about the firm-specific non-pecuniary aspects. I care about the firm-specific or the match wage, and I care about the match utility. So those are the 4 things that I care about. When I care about compensating differentials, search isn't that important for wage inequality because I'm not only looking for high wages. I'm searching, but sometimes I choose higher wage jobs, sometimes I choose lower wage jobs. The overall effect on earnings inequality is not that much. So that's why, like in this case, it's not very much. But if I look at D, what am I looking for? For D, I'm only searching for the wages. So D, the only thing, because I got rid of compensating differentials first, so I'm no longer searching for good job matches. I'm only searching for good wages. And if all I cared about was wages, then search frictions would be way more important. So these things interact. This is a case where the order in which you do the decomposition matters, but it matters in a way that I think is interesting. Okay, I'm gonna let you go. I'm not gonna take the extra 5 minutes because it's late and it's time for pizza. And I'll just quickly sum up that search friction is not pecuniary. It looks in that they don't matter. They matter for other stuff. Okay, and in particular, rather than looking at wages, we can look at utility. Right? So part of the reason why compensating differentials and search don't matter is because you don't only care about wages. If we look at their contribution to utility rather than wages, it's much larger. Okay. By the way, this is something. This is the wage thing was non-parametrically identified. This is not non-parametrically identified. Depends on the functional forms that I picked. But it suggests that there are aspects, even though Roy inequality is the most important thing for wage inequality. If I look at overall utility inequality, compensating differentials and search frictions matter. So the point is, all these things matter for labor markets. If you're thinking about modeling labor markets and you want to care about earnings inequality, you should really care about all three of these things. And let me end with an ad, which I think this is a framework that, you know, there's lots that can be done to build on this and add different aspects to it and make it richer in lots of dimensions. I think it's a really nice framework to start with, which is kind of why I want to talk about it. So that's it.